Okay, why don't we get started? My name is David DeWitt. I was a professor for a long time until I joined Microsoft about 4 years ago. That's why I'm pushing Microsoft's cloud on CERN. But as a database guy, I like to see CERN using databases. The NIF people showed that you could actually use databases successfully, but physicists still don't get it. This is a non-panel panel, so I'd like to apologize for that. It's my fault for not paying closer attention. The panelists were supposed to read the title and address the subject area of the panel title, which was supposed to be, is Hive a database system, and then got morphed to, can we make Hive a better database system? So the way we're going to run this is we're going to have four relatively short presentations, and then we will have an open discussion period among ourselves and the audience. So I hope that's okay. If you came to hear about is Hive a database system, you're going to probably be disappointed. But you know, false advertising is not uncommon. Anyway, okay, so we're going to start with Mike McIntire from Sears, formerly from eBay. Turn it over to Mike.
I'm going to set this up just a little bit before we talk about this. The panel, I'm going to kind of talk about some principles, and I stripped all the patterns part out of this deck. It's a deck that I give internally. After many years in this business, you know, I've been mostly consulting and working in the Fortune 200 in engineering and in architecture roles. And so you end up with a series of principles, right? You get these great big ecosystems. And this is really about what principles do we have to apply, right, to be successful in those ecosystems. And they're really simple. I'm not going to tell you anything that you haven't heard before. Hopefully, I'll set up some of the discussion so that when we're all sitting up there, you can toss lots of grenades at us. Did it meet this test or that test? So that's all this is really about. Some of the slides are fun because of where they were. All the images, by the way, from my stock photo, kind of fun. I carry a copy of the Constitution around in my briefcase, right? And every one of us that comes from a democratic country has a Constitution. It's this very small document, and yet it instructs the ecosystem in which we all live in our various societies. The one fun piece that I like to make is that, you know, it's like, how does the Constitution contribute to an 80,000-page document which governs the IRS? Right? I don't know that that's necessarily right, but the point is it's set up from a foundation of small principles, okay? And we should all be founding ourselves in a set of principles that guide us into dealing with the ecosystems that we build. This one, as we all know, is probably the most fundamental thing when you build a big ecosystem. Keep it simple, right? This is actually a principle that applies mostly to the majority of systems that we have to build. Every time I add a new system, and as a consumer of technology, I have to knit them together, right? I have to write some glue, or I have to use some ETL, or I have to generate some logic. I now have to manage that logic. I have to care and feed for it. A lot of things that I have to do, right? And the more of it I have, the less simple it is. The more complex it becomes, the less governable it is. And ultimately, it means that I'm less agile. Second fundamental principle, time to market. All of us kind of have this problem, right? I heard someone talking earlier about one of Oliver's famous principles is, you know, by the time we get to building something from a set of requirements, the business either already built it or it's obsolete. It's true. And this is really the foundation of why we need self-service tools, okay? This applies to everything we do. It applies to patterns. It applies to infrastructure. Right? We need to do many, many more things with many, many fewer things. So when I look at products like Hive and Hadoop and all of the other platforms we have, I have to deal with the, okay, I have to retrofit something. How complex does this make it? Right? The people that have to maintain this stuff in large corporations are never the people that built it. And the lifespan of most systems is 10 years today. We're still running mainframe code that was written 40 years ago. Where are those assembler modules, actually? The point is that there's a bunch of people that are now maintaining that code that came out of college where they weren't teaching assembler. It is not a required component of the curriculum for a computer science degree anymore. Where do I get them? This is actually the large majority of code. I shouldn't even say that, I said it earlier, right? We already know that the people that are going to maintain your code base are not the people that wrote it, okay? And yet we incur more and more of this investment, essentially. Time to market just essentially says, look, how do we get something to market, and do we set up the infrastructure such that it's reusable, right? Can we move quickly and yet efficiently over the long term? It's everything. You guys all know this one. This is actually a funny slide. I don't know if you can see that from up here. It's not on my monitor. The CIO, Keith, is English. And so this is a depiction of a red double-stacker bus in London, which was reused as a fish and chip stand. Now, how you go from transportation to food, I don't know, but it's a good example. There's another thing up here that says essentially that reuse is not just about code. And it's about how do we reuse an organization and be efficient across a broad spectrum of components of getting something done. And it's not just engineering that gets things done. It's sales and marketing and management and maintenance. It's all those processes, all that soft stuff. That's where the majority of money goes, right? If I go buy a database and I build that database, I'm going to spend more money integrating it into the processes that I have than I did on the database, and yet the budget line item was only for the CapEx that it cost me to either license it or buy it. Where are those other line items? How am I accountable to my corporation for all that money I spent and incurred going forward? We all have this problem. We have to make every platform and every component reusable. And if we can't, okay, fine, can we rationalize it in that sense? Another thing Oliver and I have talked about a lot. By the way, I work for Oliver. He would be here, he's on vacation. That's another story, I won't embarrass him. Designing for the unknown. This is a principle that essentially says don't overinvest. Right? You don't know what this thing's going to look like. And in the analytics world, sometimes we don't have a choice, right? I saw the two presentations this morning, and I think to myself, well, there isn't any way but to invest in something that's relatively permanent. It's out at the edge of scale, and we just don't know, right? So you have to overinvest in that environment. But largely, we don't. If I build a data mart because somebody in some business unit wanted to answer a series of questions, I can guarantee that if they overdid the data model, they overinvested. Because the second query is going to break the data model. We try not to transform things. Right? We want to design for the unknown. Leave them in as near source normal form and do as little as possible. Okay? Yeah, sometimes not. Fair. You guys can pepper me with the questions on that one later. Anybody know about this project? Hopewell project in Bangkok? No formal study, no timeline, no milestones built. They spent $3 billion before they killed it. And it still sits there. If you're going to fail at something, I've heard this a couple of times, right? If you're going to fail at something, let's set it up so that we do it early in the process, right? When it's a lot cheaper to fail, and you can go off in another direction, do something the right way, or something that's at least going to be productive. If you don't fail occasionally, you're not taking enough risk. If some part of your team doesn't go out there and do something and say, well, that didn't quite work out, then if you're only doing things that actually work, well, it's kind of hard to be out there on the edge and satisfy agility and other things like it. Time to market tends to fail when you always succeed. I'm moving right through this. We're going to have some extra time. Late binding. Picture of the Arc de Triomphe. This essentially says, don't invest until you have to. It goes back to investment as a holistic view of what we have to accomplish, right? There's a whole lot of things that we have to do. In our shop where I am today, they're fond of saying, we have one of everything. And I think we have 5 different commercial MPP systems, okay? And so what did we have to do? We end up moving lots and lots of data around. So we write a bunch of ETL code. We write lots of this code, and it's external to the database, and it's managed separately, right? Different modules, different things. So we invested in a static component, right? We did not late bind this stuff. We invested up front, right? And so that investment, right, at a minimum cost takes several months instead of me going and answering a question, right, which I might have to spend more from a query perspective, but if the data was all in one place, I can answer it in hours instead of months. This goes back to the time to market problem, right? When something becomes used enough to invest more money in making it more performant, then go to something static. Until that time, use late binding. Okay? You can use this in a lot of different places. One of my favorites, the story I teased my mother about. We lived about 500 feet away from the local library. And when I was a kid, I used to come home from the library with an armful of books. And one day my mom said to me, she said, "Why are you bringing them home to read them? Why don't you just stay at the library?" Well, how many of us do this? How many of us watch our peers and everybody yank the data out of the database or the data store or the file system and apply the function on their laptop? For those of us in the commercial environment, I mean, oh, well, Mr. Data Consumer, you're trying to put a billion rows into your Excel spreadsheet. That's working out, right? The reason we're calling you is because the straw overheated and melted. This is a tough problem for those of us in the really large data spaces because some functions just don't parallelize well. Parallelize. I missed a syllable. This fundamental thing is something I take to every meeting. It's in the portfolio of stuff where you say, look, move the function to the data first. If that fails, then we can talk about doing something else. But always put it where the data store is. The people in this room and others have spent a lot of time thinking about how do we make those functions work. But we fail to propagate this into the business a lot. We think about this naturally, but we don't go talk about it. Move the function to the data every time you can. This is a very unpopular slide with our crew. I try and tell them, when you guys make a structure and you publicly say that this is the structure through a dictionary or whatever, every table is an API. And if we think about it as an API, we give it a little bit more due diligence, right? Because I can't go open up the code base in my corporation, right? Sears is a Fortune 50 corporation. I can't go open up the entire code base for a table, right, that's been around for 20 years. I may not even know where all the code is. So I've engendered a maintenance problem, right? And if we don't think of these structures and of data as an API, right, we don't give it enough due diligence up front. Another way to look at this I'm not going to go down that line of thinking. It is a trust agreement. And on Hive and many of the other late binding systems that we have, the data becomes the interface to all other things, right? And we write code to that. Even when we call it unstructured code, it is structured. The first thing that we do in Pig or in MapReduce or whatever it is that we're going to use is we apply some piece of procedural logic to it and we create structure out of it. First thing we do. So what did we do? We created an API. It might only persist for a small period of time, but the point is that we have to think about it that way. If we think about what are the key components of these things, when we implement, we'll save ourselves a lot of trouble down the line. If we have to expose it to other people, and we think about it as an API and we publish it that way, then it will get due diligence. I don't have to change it, I always augment it. I beat that one to death. We talk a lot about this one. In a lot of shops that have been around for a long time, they kind of lose their way about development patterns. And development patterns are very interesting because it starts a conversation about, is this something that we already know how to do, or is it not? If it's something we already know how to do, and there's an established pattern for it, then what are we deviating from, right? In the discussion about, is this the right architecture, if it's already a pattern and we know what its boundaries are, leave it that way, right? If it's a new pattern, now we can go apply a bunch of new scrutiny to it and do the appropriate investment to know whether or not we need to do this again, whether we need to improve it, does it work, is there some other way to do it, is it cheaper, better, faster, is there some new technology, what's the cost of implementing that into my ecosystem, et cetera. It guides the discussion as well as helps other people apply knowledge from a bunch of people to a singular problem repeatedly, that being cheaper. It's also a fundamental thing of prototyping is not engineering. And we see this a lot, right? Everybody's under the gun to get things done. And we say, go write a prototype. Okay, great. So we went and wrote a prototype and we validated something. That doesn't mean that we need to put that code into production. A lot of code that ends up that way, and it ends up being a maintenance problem later on because we didn't go back and do engineering. You need instrumentation for logging, administration. How does my ops guy roll this stuff out without a developer who does occasionally need to go on vacation? Well, not in our shop, but that's a different problem. There's something wrong with this slide. This is the test slide. I'm going to pick on somebody. Anybody know what's wrong with that slide? What corporation on the planet is the least transparent that we know of? It's a great picture of the Shanghai. And it is also funny that I'm up after Tim Cook. Anybody know what happened? It's 11 now. No takers, yeah, okay. I can't imagine this is more interesting than that iPhone 5, come on. Yeah. Transparency is very, very important. It is one of the fundamental components of simplicity, right? I talk to the engineers about this because I tell them the story about how somebody else is going to be maintaining their code. You can write a blasted fancy algorithm and implement it with the most sophisticated C function that I will never be able to figure out in 5 hours. And that's the wrong way to do it, right? If I use too many levels of abstraction and I can't explain it to somebody, then it's no good in production in a big corporation. You have to make it simple. You have to make it transparent about what it does and how it does it. I don't know that we have classes that teach how to write code in a transparent way. How do we take complexity out of the process? This also applies to architecture. Architecting not only products, but infrastructures. The CERN talk today was very good because it's actually a simple architecture. It's very simple to understand where everything goes and why it's there. Transparency as to what you're trying to solve and how you solved it is very important as a principle. And the deeper those tech stacks get, the more as an architect I go, you know, I don't want to do that. Right, you start introducing a bunch of layers in between ODBC, JDBC, and the data store, and I go, you know, too much stuff to go wrong. Or somebody needs to own the whole thing and label it as one thing so that I can go to Git and there's a simple install. Boom, entry point, gone, done. Yeah, 2.5. Data by reference. I am a little tired of the fact that I walk into a shop and I now have 10 persistent data stores and none of them talk to each other, and I invested 70% of my staff time in moving the data around. As an industry, I think we need to stop doing this. I think that we need to start making our data stores talk to each other at a low level. Let the data store figure out the geometry of the parallelism of each system. Right? How do we transfer that data around? We have these systems. How do we remove the cost of making them talk to each other? In addition, right, even when we're on a platform where we have lots and lots of different data stores, we need to do things by reference. We are so used to doing data by copy. It's incredibly wasteful. Incredibly wasteful. How many of you walked into a shop or you've been talking to the guys and you find out you have 10 to 50 copies of the same stuff with slightly different definitions or a slightly different set of rows in them? We have to figure out how to do this stuff, which is data by reference. We'll do more of this. Pretty much last slide. Get the keys right. Unstructured or structured, right? If you know what the keys are by the relational definition of something, and it's in everything, whether you have to get through it through procedural logic or otherwise, it's there, right? You have to be able to define how it is that you access that data. If you can do this, then you can share the data across an enterprise, which for me, right, I have 350,000 employees in our enterprise. They probably don't care about keys a bit. But if I do my job and the 1,200 people in our organization do their job and they get this piece right, mostly the rest of it will fall into place. It's a fundamental principle. I ask them all the time. You're going to deal with data, get the keys right. The entities and the keys, those definitions, you have to know what they are, not necessarily how they're implemented. Leave you with this tidbit. For those of us in the great big data shops, right, you have all this data. It just, by definition, when you have that much data, you're going to apply multiple problems to that single set of data. Very interesting point today about if I have all of the data and it's very expensive to build, keep it all. It's kind of the same point. It's an ecosystem. We need to reuse it. Thank you.